Hello and welcome back. So we've now made our 3D models. We've displayed it in our map, in our uh, you know 3D and 2D views. Now I want to go beyond that. So one of the common workflows that we see people using is they have a horizontal well that they're going to drill, and they want to know what the expected gamma ray pattern, or maybe the gamma ray and the density pattern should be for this yet to be drilled well. And they want to base that on the 3D model. So allow me to show you how we can do this here. So we'll do this by making a couple of flows. So first thing I'm going to do here is I'm going to right click. I'm going to say new flow. And I am going to call this, this first flow that we need to do is we need to make empty LAS files based on our deviation surveys. So I'm going to call this make logs. And what we'll do is we'll start with a points input, and we will get our deviation surveys. And one thing to note is we do have a lot of wells that are outside of our survey, that are outside of our area here. So what I'm going to do is I am going to filter this down here. So I'm going to select a polygon, and I'm only going to select wells that are inside our 3D model, because otherwise there won't be anything to extract here. And so I'm just going to save those APIs to a points file, and we will call this, wells to extract. We'll say OK. And we'll come back here to this flow, and now we'll say points select, and we will select by points file, and we'll choose the wells to extract points that we just made, and we will choose the column API. All right, now that we have that, we will use points to logs to turn our points into a logs column. So we need to select the API and the depth columns. And actually here I selected my unprocessed deviations. I need to select the processed deviations. So remember, we always work with those processed deviations going forward. So we'll take API and measure depth as our columns. And now what we need to do is we need to turn those we need to write the logs out. Now, deviation surveys are irregularly sampled, and I want to have regularly sampled logs. So I'm going to add a log resample in here, and we're going to resample on a half-foot depth step, and then we are going to write these logs out using a log output. And I'm going to call this empty logs here. And we'll hit the run button. And what it'll go through and do is it'll grab our process deviations. We are filtering that down to the wells that we actually want to extract here in the future. We're going to convert those into logs. We're going to resample them on a half-foot depth step, and then we're going to write that out. And this made this empty logs.ldb. Now it's not truly empty because we have, our measured depth, our TVD, our dx, dy, and our inclination in here. And if this was a deviated well, we would of course see this, have some more variable values in there. All right, so that was our first flow. Now we're going to make our second flow, which is how we do the extract. And so once again, we'll say new flow, and I'm going to call this, extract here. And what we'll do is now we'll start off with a log input, and we will grab the well log database that we just created, in this case the empty logs, and then we'll use the log volume extract tool, and we are going to grab our headers, our process deviations, and we'll tell it the volume that we want to grab. So in this case, our gamma ray volume, and we're going to call this, we'll give it a name, GR model. And we can have multiple log volume extracts in here. So we're going to grab our, once again, our process deviations, our headers. Now we'll point at our density volume. We'll call this RhoB model. And then we need to end with a log output. And we will call this extracted logs.ldb. And we'll hit the run button here. And once again, what this flow will do is it takes those empty logs that we made with our previous flow. It will then go and it will look at the deviations, the headers, and the gamma ray volume, and the same for our density volume, and then it is going to write that out to a new well log database. You'll notice this is a fairly quick process. We're already at about 50% done, and even if you are extracting from several different models, this process will be fairly quick. All right, so now what we have here is we have this new extracted logs.ldb, and you'll now notice that we have a curve called gamma ray model and RhoB model in here, and you can see that we have extracted this from our database in here. So that is, and we've done this for every one of the wells in our project here. So, number of different wells where we've done this extract. All right, so what I'm going to do now is I'm going to find one of these wells that is a horizontal. So I'm just going to pause the video and find that, and then we'll be right back. Okay, so here is a well here. It's API 490052610520000. It's on the second page of our well log database. And what you can see here is you can see the TVD is increasing, and then it goes, essentially goes flat, and that's because our inclination has kicked out here to almost 90 degrees. As you can see, very slightly deviated, very steep build, and then we go horizontal. And what you can see is as we go through the model, here's what the expected gamma ray and RhoB character would be as we go through here. Remember, our model's on 10-foot resolution, and we have 1,000-foot grid cells, so we should expect this to be a somewhat blocky character in here. But that is what our model will look like for our modeled gamma ray for this well. And now you could take that and use that to help you when you're doing things like your geosteering. All right, well, congratulations. You have now made it through the welcome project for 3D property modeling. If you need any help, feel free to contact us at support@danomics.com. And if you don't have access to the 3D property modeling license and you would like to have that, contact us at sales@danomics.com. Thank you.